So I have a new form of an equation for a parabola. It's got these two brackets. We just saw a vertex form that had one bracket, which showed you the one location of the vertex. This one has two. So it's telling you the location of two somethings. What that is, we'll get to in a minute. Just to convince you that this is in fact the equation of a parabola, because it does look different than the other ones, I'm going to try doing the actual FOIL, like the multiplication. So this notation says everything in here has to multiply everything in there. So I'm going to pick something from this bracket, the x. I'm going to pick something from this bracket, pick the other x. Then I'll maybe take this x with the -7, and then I'll take the -3 with the x, and then I'll take the -3 with the -7. Now, if you look at that line, there are no other combinations of something from the first bracket and something from the second bracket. That means I've accounted for all the possible combinations of something from here, something from there, and they've all been multiplied together. So that is how this multiplication would expand. Now that leaves me with an x times an x, which is an x squared. -7x's minus 3x's is -10x's. And -3 times -7 is 21. And there you have the equation of a parabola in standard form, which we have been sketching. So this format does indeed make the parabola pattern, just like what we're used to. So the question is, how do you use this thing to sketch? So just going to clear this out of the way here. And the trick is that these things are showing you where the x-intercepts are. So if you think about an x and a y grid, and you have a parabola coming down like so, if it crosses the x-axis, it's going to cross in two places, there and there. So I would need two things to show me where it crosses. Now, if you look at where x-intercepts are, those things happen when y equals 0. So I'm just going to put that here for a minute. Now, here we're going to have to pull out a nonlinear algebra technique. We're going to have to set up some cases. So what I've got here in my algebra, it says that something, I don't know what that's worth, multiplied by something else, I don't know exactly what that's worth. Those two things multiplied together equals 0. Now, there's only one way for that to happen, is that either this object is 0 or this object is worth 0. Because the only way you can get 0 through multiplication is 0 times something, or something times 0, or 0 times 0. Perhaps they're both zeroing out. So I'm going to take this equation and I'm going to split it into two pieces. Case 1, case 2. So I can get a thing times a thing equaling 0 if the first thing is worth 0, or I can get a thing times a thing equaling 0 if the second thing is equal to 0. Either way, this will work. So if I finish this case, I just have to add 3 to the other side. I get x equals 3, and here I have x equals 7. So when x is 3, the y value is 0, which means I'm sitting right on an x-intercept. When the x value is 7, the y value is also 0, so I'm sitting at the other x-intercept. So now that I have those pieces of information, get myself a grid, draw an X and Y axis. Make sure it's straight for my obsessive compulsive disorder. So I have an x-intercept at 3, 1, 2, 3, and I have an x-intercept at 7, 2, 3, 4, 5, 6, 7. Okay. Now what to do with that? Because I can't draw a parabola with only 2 points. But do you notice that in any parabola, it is symmetrical? So I've got those 2 pairs there, right? The dots always come in partners. So if I've got a dot here and a dot there, the line of symmetry must be halfway between them, right about there. So I'm just going to pencil that in. Now the vertex is going to be somewhere down here, because I'm going to take a step over and add my first perfect square value, which is 1. Then I'd add my next perfect square value, which is 4, then 9, then 16, from wherever that count line is. When you did vertex form, or when you did standard form, you had the count line, and you used that to generate the pattern. This one's a little backwards. I have to use the pattern to figure out where the count line is. So looking at these 2 dots, this one is 2 squares out. So if I look at my list of perfect squares, that's no squares from the vertex. That's 1 square from the vertex. This is 2 squares out from the vertex. This dot has to be 4 units above the count line, which means the count line is 1, 2, 3. It has to be here. Just to confirm, if that is the vertex, take a step, you have a dot. Take 2 steps, you go up 4. I've hit this x-intercept, which is good. Take 3 steps, 1, 2, 3, up 9, 1, 2, 3, 4, 7, 8, 9. Same thing going the other way. 4, 5, 6, 7, 8, 9. And I have enough to sketch in my parabola. It's kind of hard to do reaching way over there and looking at it from the side. There we go. So I had to look at these 2 x-intercepts, decide where the axis of symmetry would be, and then based on how far this x-intercept is from my line of symmetry, I had to go to that number in the pattern to figure out where the count line should go. Once you've got that count line in there, the place where the count line and the axis of symmetry cross is right where the vertex will be. I have another example here. So I'm looking at this thing and I see 2 brackets, which means it must be in factored form. Factored form shows me where the x-intercepts are by setting each of these little pods to 0. I'm going to add 3 to both sides. Subtract 5 from both sides here. So I have an x-intercept at 3 and an x-intercept at -5. So I'm going to draw myself a grid. And I'm going to pencil in an x-intercept at 3, 1, 2, 3, and an x-intercept at -5, 1, 2, 3, 4, 5. So again, I've established a pair of dots here. The parabola has to be symmetrical around the vertex, wherever that is. So I'm going to try and count in to the center to find where my line of symmetry would be. So these are 1, 2, 3, 4, 5, 6, 7, 8 units apart. So the line of symmetry should be 4 units from each side. 1, 2, 3, 4. 1, 2, 3, 4. There, dead center. So the vertex of this thing has to be sitting on that axis of symmetry. To figure out where, like how far down to go, I keep in mind my squared number pattern, 0, 1, 4, 9, 16, 25, etc. This dot is 1, 2, 3, 4 squares out. So that's on the vertex. That's 1 square out, 2 squares out, 3 squares out, 4 squares out. The count line has to be 16 squares below this x-intercept because this dot is 4 steps away from the axis of symmetry. So if I count down 16, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, just made her there. Then my vertex has to be sitting in this spot right here. Once I've established the vertex, I just use this number pattern to fill in the rest of the dots. 1 and 1, 2 and 4, 3 and 9, 4 and 16, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I landed right on that dot where it should be. I'm going to use symmetry to establish where the other dots will go. And I can just connect in my pattern. It's grabby today. All right, so I'm going to clear this off and we'll do an example with a negative, we'll do an example with a whole number, and we'll do an example with a fraction, and then we'll be good to go for practice problems. And you saw in the standard form sketching and the vertex form sketching that if there was a negative sitting out in front, or a negative attached to the thing with the x squared, that instead of adding to the count line, you were subtracting from the count line. So that ended up taking a parabola that was normally shaped like this and turning it into a parabola shaped like a frowning face. So that's going to do that to this particular parabola, but it's not going to change the fact that these things are generating the x-intercepts still. So I need to figure out what those are. First one happens when x plus 2 zeroes out, and the other one happens when x plus 8 zeroes out. So subtract 2 from both sides here, I get negative 2. There's one x-intercept. Subtract 8 from this side, you get another x-intercept. So I'm going to set myself up a grid, and I'm going to plot those on there. So the first one is at negative 2. 2 would be here. And then negative 8, 4, 5, 6, 7, 8 would be there. Now, I had to recognize that because there was a negative in front, I'm ending up with a parabola shaped like this. So my vertex isn't down here this time, it's going to be up there, so that I get that upside down shape. But even when they're upside down, they're still symmetrical, so I can still find the vertex by looking dead center. So these are 1, 2, 3, 4, 5, 6 apart, so the midline should be 3 units from each. A little wobble there. 1, 2, 3, and 1, 2, 3, dead center. I'm going to get my list of perfect squares again, 0, 1, 4, 9, 16, 25, etc. These dots are 3 steps away from the vertex, so that's on the vertex, 1 step away, 2 steps away, 3 steps away. This is the one I need. So this vertex has to be sitting 9 squares above this dot. So I'm just going to find that. 1, 2, 3, 4, 6, 7, 8, 9. That's where my count line needs to be in order for this to be 9 squares below it. The place where the midline and the count line come together is where I'll find my vertex. And then I just need to add my dot pattern from there. 1 and 1, 2 and 4. Grid's getting a bit worn, it's hard to see. 3 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 9. Good. Is where it needs to be. 10, 11, 12, 13, 14, 15, 16 would be sort of off the grid. So I can connect my dots like so. And I get a lovely upside down parabola. We're going to an example with a number out in front. So that's going to change the counting pattern. You're just going to take all your perfect squares and double them. But before we get there, we can still use these things to find the x-intercepts. So when x minus 4 equals 0, there will be an x-intercept. And when x minus 8 equals 0, there will be an x-intercept. So add 4 to both sides, add 8 to both sides. There are my 2 x-intercepts. Grab my grid. I will plot my x and y axis. So I have an x-intercept at 4, 1, 2, 3, 4, and an x-intercept at 8, 5, 6, 7, 8. So my line of symmetry has to be dead center between those. Notice none of this is different for that 2, not yet. Dash in my line of symmetry. Okay, now I'm ready to think about this 2. First off, it's a positive 2, so the parabola is going to open this way. It's a smiley parabola, not a frowny one. So I will be counting up from the count line. The vertex has to be down here somewhere in order to get that kind of shape. Second, instead of using 0, 1, 4, 9, 16, etc., I have to use this pattern doubled. So instead of 0, it's 0. Instead of 1, it's 2. Instead of 4, it's 8. Instead of 9, it's 18. Instead of 16, it's 32. That will probably be off my grid, so I don't need any more of them. So now that I have my double x squared pattern, that's these, I look at my dots. I see that this is 2 steps away from the vertex. So that is on the vertex, 1 step out, 2 steps out from the vertex. I need my count line to be 8 squares below this x-intercept. I'm going to put it in. 1, 2, 3, 4, 5, 6, 7, 8. Dash it across. Recount to make sure I'm sure. 6, 7. Yep, perfect. And once I have my axis of symmetry and my count line in, I know the vertex sits right on the place they cross. And then my pattern will be over 1 up 2. Would normally be up 1, but I've had it modified by this 2 in front. Told me to double all those pattern numbers. Next step out should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. The next one should be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, it's just squeaked her again. And it will have a symmetrical partner over there. And I can connect those dots to make my parabola. So the number in front didn't change how you find the x-intercepts. It didn't change where the x-intercepts would be, but it did change where the vertex would be relative to those dots. It made it deeper than a normal parabola pattern would be. And that happened in both the sketching of standard form and vertex form. When you put a big number out here, it makes this thing grow more aggressively. So it shoots up faster than it normally does. The last example, I still have this in factored form. I can tell it's in factored form because I have 2 brackets sitting here. This one has a negative in front and a fraction in front. So that's going to change the shape I use for the pattern, but it is not going to change how I find x-intercepts. So I'm going to do them first. First x-intercept happens when x plus 2 equals 0. The second one happens when x minus 6 equals 0. Now I can subtract 2 from both sides here. So I have an x-intercept at negative 2. And add 6 to both sides here. I will have an x-intercept at positive 6. So I'm going to set up my grid. I can get those things plotted on there. All right, so an x-intercept at negative 2 would be here. And an x-intercept at 6 would be 2, 3, 4, 5, would be here. So from those 2 things, for the 5th and final time, I can plot in my axis of symmetry, dead center between them. They are 1, 2, 3, 4, 5, 6, 7. They're 8 apart. So it should be here, 4 away from each dot. A negative parabola opens this way. So my vertex is going to be up here somewhere. I normally use this pattern, 4, 9, 16, 25, etc. But in this particular parabola, the perfect squares are only half powered. So I'm only going to be using half of those square values. Half of 0 is 0. Half of 1 is 0.5. Half of 4 would be 2. Half of 9 is 4.5. Half of 16 is 8. Let's put some commas in here so we can tell them apart. Half of 25 would be 12.5, It's probably on my face. All right. So this dot here is 1, 2, 3, 4 steps out from wherever that vertex is. So this part, this should be the count on the vertex, 1 step away, 2 steps away, 3 steps away, 4 steps away. My count line has to be 8 squares above this dot in order for the pattern to work out. So I'm going to count that up. 1, 2, 3, 4, 5, 6, 7, 8. Here's where my count line is going to be. So I can see that the vertex is going to happen here. And if I follow these number patterns, if I step 1 away, I should be down 1/2. Step 2 away, I should be down 2. Three steps would be 4.5. 1, 2, 3, 4.5. 1, 2, 3, 4.5. Next one should be 8. 1, 2, 3, 4, 5, 6, 7, 8, which I knew because I built the thing based on those. Next step out should be 12.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5. It will have a symmetrical partner over there, and I'm able to pencil in that vertex, or parabola rather. That's embarrassing. Nice and smooth, nice smooth curves. All right. So net, these two things are going to generate x-intercepts for you no matter what the number is in front. If you see a fraction, you handle it just like you did all the other ones with fractions. If you see a whole number, you manage it just like all the other ones that had whole numbers. Negatives make it a frowny face kind of parabola. Positives make it a smiley face. So you should be able to get onto the practice problems and give them a try.